Alright, so this is the solution to homework accuracy covering corresponding parts of polygons and also some information about triangles. So we'll start with quadrilateral here, a four-sided polygon that is and we have two congruent polygons in this case, A, B, C, D, and W, X, Y, and Z. So one of the strategies that we've learned from this is to draw a diagram. In this case, I'm actually going to go ahead and not draw a diagram, and I'm going to show you a different strategy that might save you some time. Now, one of the strategies, or this strategy will include the use of some highlighters. Okay. In this particular case, what I'm going to do is I'm going to highlight corresponding parts, okay, and I'm going to highlight them the same color. So starting with the first one here, I know that if A is the first vertice listed in my first quadrilateral, then W, being the first vertice listed in the second quadrilateral, must correspond with it. And we just go in order in this way. B is the second vertice in this one, so X will be the second vertice in this one. And I'm using, as you can see, I'm using a different color for each one of these. C is the third vertice, so it needs to correspond with the third vertice of the second one. And I'm going to leave the last one not highlighted, and the last two are corresponding as well. Now, one of the things that we do know is that corresponding parts of congruent polygons are congruent. That's true of any polygon. So if I'm going to start with the angles, not only can I do two corresponding angles, okay, and I would actually in fact know that these are congruent, okay, I can do actually up to 4 of them. So here I know that angle A, the angle formed by that vertice, must be congruent to the angle formed by that vertice. Okay? Okay. And then we can move on to yellow. And in this case, I know that angle B, okay, since B and X both correspond, the angles that they form must be corresponding and congruent as well. And we can go through all of them this way. Moving on to our green corresponding angles, we have that angle C is congruent to angle Y. And lastly, we can say that the two non-highlighted angles, angle D and angle Z, angle D and angle Z, are in fact also congruent. Now these are both congruent and corresponding, each one of these pairs. Corresponding pairs. Now the next strategy is a little bit more challenging, but what we're going to do, okay, is we're going to simply state, well, I know that A and B must connect because they go in order. And remember, when we're talking about a quadrilateral, we don't skip. So if I have a quadrilateral and it's A, B, C, D, okay, I know that A and B must be connected. So it'll go A to B, B to C, C to D, and W to X, X to Y, Y to Z, and then it loops back around. So that's actually another side that we can use. Now, that being said, what I'm going to do in this case is I'm going to start, and my first set of corresponding sides are going to be from pink to yellow. So if I go from pink to yellow here, I can see that on this side I'm going to go from A to B. So line segment AB will correspond and will also be congruent to, well, from pink to yellow, WX. moving right along to the next one here. Okay. And I'll do one more, and if you choose, you can go ahead and do a second one. I can choose any one that I want. Well, I'm just going to go in order because I think that'll be easiest. And I'll go from yellow to green. And from yellow to green. And if I go from yellow to green in the first polygon, I'm going to go from B to C. Well, I know that that line segment has to be congruent to the line segment that goes from the yellow to the green in the second one, X to Y. Now, if you're still not sure, what I would recommend is drawing two congruent figures. Okay. And obviously those don't look too terribly congruent, but we can just use our imagination slightly and label them the same way, and you can go through the same strategies that we just described here. Now moving on to number 2. Number 2 requires that we have some information, or that we prove that these two triangles are congruent, if we can. So first we're going to go ahead and fill in as much information as we can. So first it says that AB bisects angle CAD. Well, if I take CAD and I cut it into two congruent into two equal sections, then I know that these two angles here, notice how I offset my congruent angle marks, must be congruent. And they also tell us that C and D are congruent. So I have C and D are congruent. Now, lastly, they don't give me any additional information. And I know that if I am going to prove that two triangles are congruent, then I need at least 3 pieces of information. Okay? And that can be any combination of sides and angles. Not any combination, but specific combinations. Well, I only see 2 angles, but then I notice that if I look at the sides, well, these look like they could be congruent, but I don't have that information. These look like they could be congruent, and I look and they actually share a side. So my third piece of information is that shared side. Now this becomes a slightly tricky question here, in that if we go in order, we see that we have angle, angle, side. The angles do not sandwich one of the sides, so we know that if we were going to prove this, this would be angle, angle, side. Well, unfortunately, this actually is a theorem that we have not yet proven. It is not a postulate, as the question asked for. So, can we prove that these are congruent? The real answer is not yet. But are they congruent? Yes, they are congruent. Okay. Now, I won't trick you up like this on the test. This was a minor mistake. But angle, angle, side is a way to prove congruency, but we have not yet proven it in our study of geometry. Therefore, we do not have a postulate, and in fact, we cannot prove that these are congruent as of yet.